Hey guys, welcome to our channel of Sciences and Mathematics. Today we are going to deal with a topic in mathematics that goes by the name matrices. Matrices is a very important concept both in maths and other disciplines, of course, like chemistry, biology, physics, etc. This is simply because through matrices we are able to solve linear equations. And of course it's used in systems that require linear and differential applications. So for that case, it's going to be very handy for us to try and find out how various concepts of matrices can be used. So basically, this is an introductory topics. The subsequent video ones that we're going to deal with. There are also going to be topics on matrices, but we're going to look at concepts once at a time. So for that case, thank you and welcome. So as I've said, today we're going to look at a topic in mathematics that goes by the name matrices. Now in this case, as we have said, the concept of matrices in mathematics is very important because in us trying to deal with some concepts of like linear equations, matrices comes handy in the sense that it will give us a clue on how to solve this kind of linear equations. And also it's used in describing systems, of course, as I've said, of linear and differential nature, and of course, and their applications. So in this topic, we're going to start by trying to define the concept of matrices and find out if someone asks what is a matrix. So defining a matrix in a sense represents an ordered rectangular array of numbers. So this represents an ordered rectangular array of numbers So this is an ordered rectangular array of numbers that are usually enclosed in square brackets or parentheses. I hope we are familiar with these two specific terms that I've used in the definition. So generally we can say that a matrix is an ordered rectangular array of numbers usually enclosed in square brackets or parentheses. So from this definition we can just try to see or figure out how this arrangement is, as we know that from that regular figure that has been mentioned, they are rectangular and that consists of numbers that are usually enclosed in these two symbols of brackets or parentheses that we've talked about. So for the case, for this, from this definition, of course, we can be able to try and illustrate this concept that we have been told. So therefore, suppose there is an array of numbers which just have been ordered in this way, and then there's a second one that is ordered that way. If these numbers are enclosed in square brackets, in parentheses or square brackets, therefore each of them can be referred to as a matrix. And in this case, the matrices are represented using letters, alphabetical or letters, which are of course in uppercase. Uppercase means they are capital letters, and lowercase, that is small. So for that case, if we say that this is a matrix, then we can say that A is represented. This is a matrix A, and it is represented as A, as that, whereby these individual dots here, suppose they are numbers from numerical figures 1, 2, 3, then we can say that this one represents a column, while the horizontal one represents a row. So in this case, if we are asked to find how many rows and columns are in these specific matrices, let's say that this is matrix A, and then the second one represents another matrix. Of course, we have said that they are represented using the alphabetical order letters in uppercase. Therefore, for the first matrix, we have the number of rows 1, 2, 3. So it is 3 rows, and then the number of columns is 1, 2. So these 2 columns. And then for B, these are the columns 1, 2, 3, 3 columns. And then we have 1, 2. So these ones we call them rows, horizontal ones rows, vertical ones columns. So in this case, of course, we have different sizes of matrices, and the size of a matrix is specified by the number of rows and columns, normally represented by uppercase. So in this case, of course, I've already demonstrated for this. Therefore, for a matrix like the first one that I've given, I've said that it can be represented using the numerical figures. If I give an example, suppose we say that the matrix A is made up of, so we have said we can use either the square brackets or parentheses, as we have said. So in that case, suppose I give an example for matrix using those specific numbers, which we are going to further look at, or maybe define in another terms, that each specific dot here represents what we call an element. So therefore I can say that matrix A is made up of elements 1, 4, 0, 3, 2, 1. So therefore, in this case, I can see that, or we can see from the definition of rows and columns that we have put, that this particular matrix A is made up of 3 rows. That is 1, 2, 3, 1, 2, 3, and then 2 columns, 1, 2, 2 columns. So therefore, we can say that A is a matrix of order 3 rows by 2 columns. So specifically, when somebody mentions that a matrix is of order 3, 2, then it means that it's made up of 3 rows and 2 columns. Therefore, we can say that matrix A is of order 3, 2. Therefore, suppose these numbers are of different kinds, they can vary, they can be n arbitrary numbers. Therefore, we're going to have a general representation of matrices. Now that we have said that there's a way in which we can be able to represent these matrices in terms of rows and columns, we're going to have a general representation for that. So for the rows, actually, suppose we have a matrix that is made up of characters. These characters can be similar. It can be 1, 1, 1, 1, all through, maybe 2, 2. Suppose there's a matrix that is made up of a character, maybe, or an element, as we have said that each individual character in those matrices is known as an element. Therefore, suppose we have we define A as a matrix that is made up of element A all through, then therefore we can demonstrate the rows and the columns, saying that this is the first row and the first column. Then element 2 will make up the first row and the second column, and element 3 will make up the first row and second column. Now in this case, then we are going to move to the next row, and therefore say that this next element for row 2 is made up of row 2, and of course, row 2 and the first column. This is still the first column, second column, third column. This is the first row. I write there the second row and the third row respectively. So for that case, if I'm writing, these are not necessary just for demonstration purposes. So if I'm writing like that, then we shall have, of course, okay, so in other words, maybe I can do an expansion of this now that we have said that these are the rows and columns, so that I can be able to appropriately demonstrate the point that I'm trying to put across. So in this case, of course, these characters across this first row will move from A. Now that we see the first subscript is constant for 1, that is representing the rows. The first row, they'll move up to m, which is an arbitrary number, maybe a small or a wide range, but in that case they move up to n. And then for this case, we shall have this for the second row, and then they remove a to n. These are the columns, and then this one will just represent 1. So therefore, at this particular point, then we shall have this element A of m rows and n columns. So this is a general representation for the matrices. And then for this, for the mn matrix that we have said that m represents the rows and n represent, of course, the columns, we shall just write it here for demonstration purposes. So these are the number of rows in that matrices, and these are the number of columns. So generally we represent the rows using the I, so I, and then we represent the column using J. So therefore, when I say that A is a matrix that has got J rows and I rows and J column, this will be just a general representation to represent a number for the number of rows and columns. So basically, this how we represent a matrix of an order mn, which is of course having the elements of A. So as I've said, these elements can be different, or maybe it can be an arbitrary value. I've just chosen A for the sake of convenience. So in a sense, this is how a matrix can be represented. And therefore, in case we come across the operations, we are going to refer to these numbers representing maybe a character that appears in row 2